Okay, guys, ladies, can you clearly see the chapter 2, lecture 9 slide?
Yes, sir.
Okay, good. Kita akan tengok berkenaan dengan impulse and momentum. What is impulse and what is momentum? Then we will look more on the linear impulse momentum principle lah. So momentum ni saya rasa tingkatan 5 you dah cover kot. Tingkatan 5 ke tingkatan 4? Something like that lah. You dah cover momentum. Alhamdulillah. Okay, last lecture, ambil lecture 8, kita dah cover mainly on method of work and energy, where things are related to forces, mass and velocity include displacement. Whatever, kalau you tengok dia punya difference between work and energy and method of impulse and momentum ni, you can see that dia pun ada force, dia pun ada mass, dia pun ada velocity, tapi untuk momentum dia melibatkan massa, melibatkan massa. Untuk impulse lah, basically melibatkan massa untuk impulse. Ini cuma dia nak cerita berkenaan dengan apa itu momentum. Kalau tengok yang ni, coach dia ada satu pertandingan ada satu pertandingan ni bola, so coach dia cakap pumps up his team up at half time, saying you have the momentum, the critical need is that you use that momentum and bury them in third quarter. So maksudnya dia tengah ada energy on that first half, so kekalkan momentum tu untuk lawan on the next quarter lah. So momentum ni, bila sebut momentum ni, saya rasa semua dah faham lah. Begitu juga kalau tengok animation ni, this guy in a red shirt berlari membawa bola, so it have it owns momentum. So player in the yellow color, this one, bila dia nak stopkan player red tu, agak susah lah, sebab this guy in the red color is having his own momentum. So the definition of impulse and momentum are actually deriving from the equation of second Newton's law. So from F equal to ma. So this is the equation of second Newton's law. Sorry dekat luar tu bising sikit sebab ada orang tengah buat maintenance. F equal to ma. So kalau you tengok, dia remainkan m, and then a is actually dv over dt, and then rearrange back the equation, you akan dapat those mv, where this mv is actually the momentum. So this is the momentum. And then when we arrange back the equation, so by right this is known as impulse, and then this is the momentum. So mv is actually the linear momentum. So from, if you look into this equation, f times dt, kalau you tengok, like say this is one one particle is subjected to external forces F eh, within a time frame of T. So like say the external forces is being applied to the particle at a time of T. So maksudnya dia akan ada satu impulse, akan ada satu impulse to the another position. Bising lah kat luar tu. Sorry. Tak boleh fokus kat tu. Orang tengah betulkan lampu. So this is M. And then actually they have a V, the velocity. So kalau you tengok pada equation ni, you can see that those impulse from T1 to T2 is actually equal to momentum at point 2 minus momentum at point 1. So this is point 1, this is point 2. So the impulse means the external forces times the second, the time is equal to mv2 minus mv1. Okay, so this is actually impulse from 1 to 2. So rearrange back the equation. Sorry, it's already redundant over here. Dia dah superimpose. Rearrange back the equation, you akan dapat mv1, momentum of 1 is plus the impulse. It's actually the momentum of at position 2. Then afterwards we will have the a bit of exercise to further understand the principle of impulse and momentum. Another expression of impulse is within this annotation lah, impulse 1 to 2. Okay. So from the previous understanding, you know that if let's say there is one particle with a mass m, with a velocity of v1, so actually at point 1, at this point 1, those particles have its own momentum and v1 impulse. Whenever the particle is subjected to external forces within t second, so it's actually plus the impulse. Whenever the external forces been induced to the particle, so it start move to the another point where it is point 2, still m, but the velocity is increasing, mv2. So it's equal to mv2. So this is the case where when a particle is being induced by the external forces. So later we'll see the conservation of momentum where there is no external forces being applied. So this is the example. If I say the particle is having its own momentum with a mass of m times v1, it's actually been induced with the external forces of f with a time t, then we call it impulse. So it's equal to the momentum of at position 2. Okay? So this is the momentum at position 2. So by right, whenever we can sketch the graph of a T versus external force. So the underneath of the graph is actually representing the impulse. So under the graph is actually impulse. It doesn't matter whether it's in x-axis or y-axis or z-axis. Eh? It depends on the motion of the particle. Sama ada dia dalam satu plane ataupun dalam three-dimensional plane lah. Kalau only one-dimensional plane, then we need to consider those only one plane lah. Kalau dalam three plane, then we need to consider three axis. What is the meaning of conservation of momentum? So before this is the external forces being implemented to the particle. So now we say that if the resultant forces on the particle is zero, meaning that there is no external forces. There is no external forces being implemented to the particle. So meaning that we can say that it's a conservation of momentum, where mv1 is equal to mv2. Momentum of point 1 and momentum at point 2 is conserved. This is in the case where, let's say, we are dropping drop one ball from one point to another point. Momentum is conserved. Okay, let's see the example 1 over here. Are you with me now, guys? Still with me? Okay, you can hear the interference out there. People are doing works outside, so there is a bit ada bunyi bising-bising sikit lah. Okay, read and understand the question first. So what we have here is actually 100 kilogram of stone. Asalnya pada keadaan rest, originally at rest position on a smooth horizontal surface. Whenever we are talking with a smooth horizontal surface, meaning that there is no mu s or mu k is equal to 0. Maksudnya licin lah, permukaan tu licin. We are not considering the frictional force. And then the stone is subjected to external forces of 200 Newton within the inclination of 45 degree from the horizontal. The external forces of 200 Newton ni, dia apply on that stone untuk tempoh masa 10 second je. Untuk tempoh masa 10 second. So the question is asking you to get the final velocity. Maksudnya dia nak cari V2 lah. And then it's asking you to get the normal force. Normal force with normal force of this one between floor and stone. So what we need to do first is you know that from the equation, you know that the impulse mv1 plus impulse of 1/2 daripada 1 ke 2 is actually mv2, where mv1 adalah actually jumlah forces pada masa t daripada T1 from to T2 is equal to mv2. So force yang terlibat di sini force yang kita nak consider adalah force yang sama arah dengan velocity. So maksudnya we need to break the external force component into x and y direction. So maksudnya this stone is moving in this direction. So by right, these forces in the component of x will be 200 cos 45. And then y ni akan jadi 200 sin 45. Kita akan ada satu weight of the stone, and then there is one normal force acting upwards. So maksudnya di sini F external forces yang bertindak adalah ini 200, masa dia berapa? T is equal to 10 second. So impulse force time T, masukkan dalam persamaan ni, kita akan dapat jawapannya lah. Okay, let's do it again. This is (200 cos 45). This is 200 sin 45. This is acting upward. This is 100 times 9.81. And then from the equation of mv2 minus mv1. So F, force acting, this is the only force acting kan. So kalau ada coefficient of friction, then kita kena buat lah, kita include lah. So this is 200 cos 45 times 10 second. M is 100 kg. V2 is the one that you want to discover. V1 it said that the stone is start from rest position, so it is 0. So solving the equation, you akan dapat V2 is actually 14.1 second squared. Okay? This is answering the first question. Determine the final velocity of the stone. The second question is asking the normal force. So normal force kita kena ambil this one je lah. Force yang pada paksi Y saja. So dia akan menjadi normal force. Question 2 is asking NA sama dengan berapa. So kalau you tengok W minus weight minus width is equal to NA plus 200 sin 45. So you tahu weight ni adalah NA plus sin 45. Then you will get NA is actually 839.5 Newton. So NA you akan dapat 839.5 Newton. Okay? Alright. Okay. On the left hand side, yang ni, kita gunakan approach momentum, impulse and momentum untuk reveal the value of V2. Cuba kita pakai the previous method on the second Newton of law where we tahu F is equal to MA. Yang ni tadi from the impulse and momentum punya approach. But now kita cuba pakai second Newton of law untuk menyelesaikan, untuk dapatkan V2. So you tengok jumlah force acting in the direction of objek ni bergerak adalah first yang ni sama dengan MA. So maksudnya 200 cos 45 is the only force, external force yang acting along the motion path. Is equal to M is 100 A. So you akan dapat A is equal to 1.41 meter. Dia akan dapat A is equal to this one. Okay, maksudnya you tahu that whenever you apply the external forces at this value, you akan dapat a constant acceleration of 1.41. So from the linear equation, you boleh pakai persamaan V U tambah AT ataupun V2 sama dengan V1 plus AT. So you boleh dapat V2, V1 tadi kosong, A is 1.41 0.41, T is 10 second. So you akan dapat jawapan sama juga, 14.1 meter per second. So maksudnya you akan dapat dua jawapan yang sama dengan menggunakan approach yang berbeza. This is second Newton of law. This is the impulse and momentum method. Okay? So this is another example of impulse and momentum. Dia boleh baca dulu dia punya soalan. So kalau kita tengok soalan ni, dia bagi tahu this actually ada satu truck. Truck A. Dia punya berat adalah 15 megagram with a velocity to the right hand side sebanyak 1.5 meter per second. And then there is another tanker. Another tanker dengan berat dia 12 megagram moving to the left. So dia akan berlanggar lah ni. Dia akan berlanggar. Dia bagi tahu if the cars meet, maksudnya accident, and couple together. Apa maksud couple together ni? Dia bergabung. Dia bergabung. So, kalau kita faham dalam momentum, dalam case ni, maksudnya dia punya equation dia akan menjadi M A, momentum of A, velocity A, plus momentum B is equal to, sebab dia kata couple, so maksudnya dia punya mass tu adalah MA plus MB, and then dia bergerak pada velocity yang sama pada kedudukan selepas dia accident, selepas dia meet up together tu. Itu maksud couple together. But here in this question, you kena consider the direction. So you tahu momentum of A ni adalah pada sebelah kanan, tapi momentum B ni adalah pada sebelah kiri. So kita kena remark to the right hand side is positive direction. To the right hand side is positive direction. Okay. Let's solve the question. You know that M A VA plus M VB is equal to M A plus M B VC. Okay? So MA is 15,000 kilo. VA is 1.5. So taking movement to the right is positive. So this is negative 12,000 kilo times 0.75 is actually 27 kilo times VC. Okay? So solving the equation, you akan dapat VC is actually 0.5 meter per second. So maksudnya selepas dia couple dia masih bergerak pada in this direction. Sebab dia positif. Okay, ni mudah ni senang kan. The next question is asking you to get this the average force between them if the coupling take place only at 0.8 second. Maksudnya pelanggaran tu berlaku pada tempoh 0.8 second je. Pelanggaran tu berlaku pada tempoh 0.8 second je. Dia suruh cari dia punya force yang terhasil semasa pelanggaran tu, cari average force yang terhasil. So apa perlu buat adalah kita kena buat satu free body diagram, either in the component of truck saja, truck A, ataupun free body diagram dekat tank saja untuk selesaikan masalah ni. Let's say I choose the truck A lah. So truck A dia akan ada MV V1 so dia ada V1 semasa berlanggar and then dia akan ada force acting di sini lah, force yang acting di sini. So kalau kita tengok dia punya equation of impulse equation, you akan dapat tadi apa? Impulse F dt adalah sama dengan MA at position 1 VA at position 1 minus position 1, oh sorry, this is position 2. MA at position 2, MA at VA at position 2. So MA 1, VA 1. MA 2, mass dia mestilah sama je kan. 15 V2 dia. V2 dia berapa? V2 dia tadi, inilah dia. Sama dengan VC lah. Selepas dia accident tadi, masa dia couple, VA position 2 ni lah dia sama. So maksudnya VA2 pun 0.5 meter per second, VB2 pun sama dengan 0.5 meter per second. Itu maksud dia. Okay, so maksudnya this is 0.5 minus this one is 0 lah kan. This is this is 15 juga. 15,000 times velocity of truck initially is 1.5. So this is the one, 1.5. 1.5. So kita akan dapat, you tahu nak cari F ni, and then masa dia bagi tahu is 0.8 second. So this is 0.8. So solving this equation, you akan dapat F sebenarnya adalah negatif 18.75 kilo Newton. So maksud negatif ni adalah dia pada to the left hand side. Untuk A ni lah. Kalau you buat untuk B pun, tanker B, kalau you buat tanker B pun, you akan dapat jawapan yang sama juga nanti. Dengan jawapan ni lah. You akan dapat jawapan sama. Okay? Okay semua?
Okay, doktor. Okay.
Alright. Boleh snap gambar?
Already snap, sir.
Already snap.